Module 4 is all about aqueous reactions and solution stoichiometry. Because if you think about it, most of the time that we're in the lab, when we're doing experiments and things, it's going to be dissolved in water of some kind. It's not usually like a solid reacting with a solid. We actually do them dissolved. So we're going to talk about all the things that go along with chemical reactions that are in a solution. So the first thing we have to talk about is what is a solution. Okay, so the general properties of aqueous, meaning dissolved in water, solutions. So a solution is just when you have a solute dissolved in a solvent. Okay, this would be considered a physical change, right? Something dissolves in something else. Usually it's a liquid. Technically, you can have things dissolved in solids or dissolved in gases. That's also possible, but we're really sticking to dissolved in liquids for right now. So by definition, and you should know these, the solute is the thing that gets dissolved. So if you're making salt water, it would be the salt. It's the lesser component, the thing that there's less of. The solvent, which is the greater component, is the thing you were dissolving in, which is usually water. Water is known as the universal solvent. There's a reason for that. We haven't really talked about atomic structure, or not, sorry, molecular structure and polarity yet, but water is a polar solvent, so it is very good at dissolving things, especially ionic compounds. So example I was talking about a moment ago was when you dissolve salt or NaCl in water, the solute is the NaCl and the water would be the solvent. So make sure you're using those terms properly. Okay. So I mentioned the fact that water was polar. What does that mean? What it means is it has kind of poles of a little bit positive side and a little bit negative side. And because water has those properties, it can attract things that have charges. This is called electrostatic attraction. Anytime something positive attracts with something negative. So since water has, and you can kind of see it up here, a little bit positive, that's the red parts, and a little bit negative, that's the blue parts, it can actually attract things that are positive and negative, like ions. Ions are positive ions or negative ions. So NaCl, you have Na plus and Cl minus. They are very good at attracting to those poles of the water molecule. Okay, so not only can water attract to the ions, it actually also attracts to itself the negative side of one. So the red side will attract to the positive side or the white side of another. And like I said, we'll talk more about this later, but this is an electrostatic attraction, which just means it's a positive attracting a negative, kind of like a magnet, a north and a south pole attracting each other. Okay, so I was talking about these ions get attracted to water, and that's what happens when they dissolve. So when you dissolve an ionic compound, what happens to those ions? Well, those ions are attracted to the water and then they pull apart. And that's how we get free floating ions. That's why ionic things, when you dissolve them in water, can conduct electricity, because those charges can move, or those ions can move. So in this little zoom in here, this is NaCl. It's a bunch of positive Na pluses, negative Cl minuses. The water, you will see the white sides, the hydrogens, are a little bit positive. So they attract to the negative chloride ions. And then the positive Na pluses will attract to the negative side, or the oxygen of the water. And then they get pulled apart and they're surrounded by waters. This is called a hydrated cation. So it's the sodium ion that has waters attracted to it. And this would be the hydrated anion. It's the negative ion that has those waters also attracted to it. You can see all of the white parts are attracted to the negative one, and all of the red parts are attracted to the positive one. So whenever you put an ionic compound into water that is soluble, this is what it's going to do. So why can that conduct electricity? Well, you may or may not have taken any physics or physical science classes that talk about it, but the only thing that you need in order to conduct electricity is moving charges. If the charges can move, electricity can flow. So since NaCl, when it is dissolved, the positive and negative ions can move, it can conduct electricity. But when it's in a solid form, they can't move, so solid salts can't conduct electricity, and that's why the difference. So this is considered, the word for this is an electrolyte. Okay, ions in solution that can conduct electricity. So NaCl dissolved in water, that would be considered an electrolyte.